Hello everyone, welcome back. This is Engineer Sen Wasapi. So in this video, we'll be looking at what is called dot product. So the dot product is simply just one aspect that we have under the multiplication of vectors. So let us find the simplest way we can understand this. But before we do that, don't forget to like and subscribe to the channel. Okay, so what you need to understand is this, that a dot product will always result in a scalar value. Okay, so remember that. Just write it here. The dot product will always result in a scalar value. All right, so what I mean is this. Say we have the following vector, let's say vector A, and it has these components: A in the I, B in the J, and C in the K. Say we also have another vector, B, which has E in the I, plus F in the J, plus G in the K. Therefore, it implies that if I take the dot product of A with B, I will only consider multiplying the corresponding elements. So I'll only multiply the elements in the I with the elements in the I, those in the J with those in the J, those in the K with those in the K. So which means that this will be A times E plus B times F plus C times G, which means A dot B is equal to A E plus B F plus C G. And this is basically a scalar value. Now, it's because I'm using variables, that's the reason why you can't see that it's a scalar, but it's literally a scalar. It's not really a vector. So let's look at an example and see basically what I really mean. Say we have examples, and in our examples we need to apply the dot product. So let's say we've been told, say, apply the dot product. Okay, so since we're applying the dot product, let's assume we have question 1, which is having the elements 2 in the I plus 4 in the J, and it's having B, which is having 1 in the I, then minus 3 in the J. So if you've been asked to say find the dot product of this, which is A dot B, I only have to multiply those in the I with the I, those in the I, so it's 2 times 1 plus those in the J with those in the J, which is 4 times what? Negative 3. So this will be A times B, which is A dot B, being equal to 2. 4 times minus 3, that's minus 12. Therefore, A dotted with B will give you minus 10. Now you're wondering why there's no J component. Sorry, not the J, the K component. It's actually there. It's because it's a 0. So that's why they haven't literally included it in this example. So most questions will be given like this, because this was a random question that I picked from one of the past paper questions I came across. So in actual sense, A looks like this: 2 in the I plus 4 in the J plus 0 in the K. And B also looks the same: 1 in the I minus 3 in the J plus 0 in the K. But if you multiply the K component with the K component, you get 0. And if you add the minus 10 to a 0, you get the minus 10. So basically won't change anything. Let's say you also have, say you have B, which is having the components 2 in the I plus 2 in the J plus 3 in the K. And C is having 1 in the I plus 4 in the J minus 2 in the K. Applying the dot product here, finding B dotted with C. Remember, those in the I with those in the I, so 2 times 1, plus those in the J with those in the J, so 2 times 4, plus those in the K with those in the K, so 3 times negative 2. So B dotted with C will give you 2 plus 8 minus 6. So B dot with C is 2 plus 8, that's 10, minus 6, that's 4. So you get 4 as your value. So that's basically how you go about applying the dot product. Now, under the dot product, there are some properties you need to know. And they are as follow. So the first property is called the commutative property. A dotted with B is the same as one saying B dotted with A. So A dot B is the same as B dot with A. It's like multiplication. Then we also have the distributive law. If you have A dotted with B plus C, this is the same as 1 multiplying A times B, like that. The way we multiply when simplifying a scalar with a parenthesis. So it's going to be A dot with B plus A dot with C. So even if you said A plus C and you had your value and dotted with A, you still get the same thing as what you get when you apply this concept. So we also have the scalar combination. The scalar combination is where you have a scalar. Let's give the scalar maybe C. The scalar multiplies the vector A, then dotted with B. This is the same as the scalar multiplying A dotted with B, or even A dotted with the scalar times B. Other related properties is where you need to understand that if you have A dotted with A, this is the same as the length of that particular vector squared. And lastly, if you have 0 dotted with a vector, you get 0, because 0 by anything, you always get a 0. Now, when it comes to the application of the dot product, in most cases, we look at how we can find the angle in between two vectors. So when it comes to application, say you have this, you have vector A and say vector B, and there's an angle in between. It's called theta. So this is Captain Theta. So if you have theta there, now theta is simply just the angle that is between the tails of the two vectors. So these are the tails, and between the two tails of theta. Now this implies that A dot B is equal to the magnitude of A times the magnitude of B times cos theta. Magnitude of A is the length of A, and magnitude of B is the length of B. Therefore, if at all we needed to find the angle in between the two vectors, or the angle to say that is intersecting the two lines, what we have to do is just to make cos theta the subject of a formula. And this implies that we have cos theta being equivalent to A dotted with B over magnitude of A times magnitude of what? B. So that's what we do whenever we want to find out the angle in between two vectors, because once we find theta, which would be the cos inverse of A dot B over magnitude of A by magnitude of B. Just like that. Now, basically, through explanations, it might not be that clear. So, rather, let's look at an example and see to it that try and understand this. So, let's say we have an example. Let's say we've been told to say find the angle between the following vectors, or the vectors below. below like that, eh? So we're having vector B, which is 2 in the I plus 2 in the J plus 3 in the K. I'm using the same vector that I used in the previous example when we were just doing the dot product. Then C is 1 in the I plus 4 in the J. Then we have minus 2 in the K. Alright, so the first thing we're supposed to do is that the steps we have to follow. Step 1, find the magnitudes. Find the magnitudes. Now when I say magnitudes, I imply the size. So in other words, I'm talking about the magnitude of B and the magnitude of what? C. So to find the magnitude of B, it's going to be the root of the component in the I squared plus the component in the J squared plus the component in the K squared. So it means you have 2 squared plus 2 squared plus 3 squared. So this will give you the magnitude of root of 17. So this will be our magnitude. And let's also find the magnitude of c. So we square the component in the I plus the square of the component in the j plus the square of the component in the k, like that. So the magnitude of c will be root of 21. Now if you want, you can always, okay, so if you want, you can always have your answers like this. So say magnitude of b, if I take the root of 17, that would be about 4.123105626. And if I round off to 2 decimal places, we have 4.12. Okay, so we can also have our answer like this for the sake of peace and to them. Then we can also do the same on the other side. So we can say the root of 21, which will basically be 4.5825755695. Therefore, the magnitude of c is equal to 4.58, correct to 2 decimal places, like that. Now, once we find the magnitudes of b and that of c, the next thing we're supposed to do is to apply the dot product. So, apply dot product. Now, basically, we know that we're having b, having these, just 2 in the I, plus 2 in the j, plus 3 in the k, and also having that of c to be 1 in the I. Sorry, I feel like I've written I in the I. There's 1 in the I, then plus 4 in the j, minus 2 in the k, like that. So if I apply a dot product of b dotted with c, what we'll get is, remember, it's those in the I with those in the I, those in the j with those in the j, those in the k with those in the k. So we're going to get 2 times 1 plus 2 times 4 plus 3 times negative 2, like that. So b dotted with c is going to give you 2 plus 8 minus 6. Then b dot c is going to give you 4. Now, once we find the dot product, step 3, let us now find the angle. So we know that the angle is cos theta being equivalent to a dot b over magnitude of a by magnitude of b. Therefore, theta is equal to cos inverse of a dot b over magnitude of a by magnitude of b. So theta is equal to the cos inverse of a dot b, which is 4 over 4.58 times 4.12. Then theta is equal to 77.76152046. Therefore, theta to 2 decimal places is 77.76 degrees. Now, you need to understand one thing. If theta, which is the angle between the two vectors, is equivalent to 90, if at all theta was equal to 90, then the two vectors will be called orthogonal vectors. Orthogonal vectors. And this implies that if they are orthogonal, then the dot product of the two vectors, which is a dotted with b, should give you 0. Very important point. Alright, so this is everything you need to know about the dot product. If you have queries, you can reach me on WhatsApp on the line 077-149-5252. Remember, slow progress is better than no progress, and let's strategize before becoming statistic. And let's push for that A+.